So today we're going to be looking, once again, continuing with how to make equations a little bit easier. And we're going to look at three techniques: rewriting, which we've been working on the last couple days; undoing, which is the way we generally have been solving math; and finally, kind of a different technique called looking inside, or the what or the blob method. So let's go ahead and jump right in. So we are looking at rewriting, undoing, and looking inside. And what we're really looking at here is just different ways our brains can think about equations in order to solve. So we're going to look at some things that we've learned how to do, and we're going to look at them a little bit differently. So our first one that we're going to look at is called rewriting. And we've already learned a number of these techniques. So what consists of rewriting is fraction busting, which we just did last class and the class before that. And we also learned that we could multiply or divide everything on both sides of your equation. And then a third one is the silly one that I called magic unicorn, which we use when we have our variable as an exponent. So we're going to look at two of these examples. Let's go ahead and start with a fraction busting example. We had a lot of examples last class, so hopefully you're feeling very good about these. We have x divided by 2 plus 1/5 is equal to 3. So we start by finding those common denominators. So we have 2, 4, 6, 8, 10. And then we do the same with our 5, 10. And then, of course, our denominator here is just a 1. And we know that 1 will go evenly into all because, of course, we have 1, 2, 3, etc. So that's going to make it to 10 as well. So our number that we're going to multiply, our least common multiple of these, is going to be 10. So we're going to put everything in our sets of parentheses, and we're going to multiply them by 10. We now take our denominator and see how many times it goes evenly into that when we're multiplying. So 2 goes into 10 5 times. 5 goes into 10 twice. And there's nothing to cross out there, so that's just going to be a multiplication problem. So now we simplify. 5 times x is 5x. 2 times 1 is positive 2. And 10 times 3 is 30. And then we're just going to solve normally. So we're going to subtract 2 from both sides. And we have 5x is equal to 28. Divide both sides by 5. And as an improper fraction, it's there is 28/5. We can also write that as 5 2/3, or if we round, we can go 5.6 with a line over it, or rounded to the nearest hundredth, of course, would be 5.67. So all those are equivalents. Okay, we'll box this one. Okay, let's go ahead and look at example 2. This one is going to be one of our items where we have our variable in our exponent. So we have 5 to the x plus 1 is equal to 25 to the x. So if you recall our notes, our first step is to make the bases the same. So they're not the same right now. However, I'm going to look at a smaller number and see if there is a way I can write our other number with a 5 as a base. And I know that 5 squared is 25, so that's one that I'm going to use. So I'm going to keep my 5 to the x plus 1 as is. I'm going to rewrite my 25 as 5 squared and put what's already up there in a set of parentheses. Now that the bases are the same, that's the point where basically our magic unicorn gets really excited. It gets glitter everywhere. It uses its horn to make those disappear. And now we're going to set what's left equal to each other. So we have x plus 1 is equal to 2x. We're going to subtract x from both sides. And we have 1 is equal to x. So checking our answer there, 5 squared is equal to 25 to the first power. So 25 is equal to 25, so that checks out. Okay, so that's rewriting. And those are, just ways to rewrite the problem to make them a little bit easier. Okay, our second technique is undoing. And this is basically how we've been solving all of our equations in the past. So our undoing is simply to solve by undoing the order of operations. So basically we have our order of operations, but we're going to start down here and we're going to work up backwards. So we're going to undo addition, subtraction, undo multiplication, division, etc. So let's look at an example here, example 3. And we're going to have x plus 1 squared is equal to 81. Okay, so there's no addition, subtraction, because that's inside our set of parentheses, no multiplication, division. So we're going to undo our exponent. So just like always, when we're undoing something, we want to think of what is the opposite operation. So what is the opposite operation of squaring something? And that's taking the square root. So I'm going to take the square root of both sides. Once again, the square and the square root undo each other. So all I have left is x plus 1. And then the square root of 81 is actually 2 answers. It is plus or minus 9. And that's because 9 times 9 is 81. But negative 9 times negative 9 is also 81. So we need to make sure we represent that. So now that we have that, we do need to split it into 2. We have x plus 1 is equal to positive 9. And x plus 1 is equal to negative 9. And now we're ready to simply solve. So we're going to subtract 1 from both sides. And my first x is going to be 8. And then I'm going to subtract 1 from both sides. And negative 9 minus 1 is negative 10. So x is equal to negative 10. Now, if I were to graph this, I can see that there's a square there. And so that means this is a parabola. So this is a different method with a different kind of starting setup where we then can go ahead and plot those roots and then find our vertex and plot it using this way. So once again, we're undoing. This is generally the way that we solve all of our problems. It's what we're doing right here with 5x plus 2 is equal to 30. We're undoing our addition. Then we're undoing our multiplication, division. So we're very used to the undoing method. So if you're just solving it normally and I ask which technique you're using, more often than not, it's going to be undoing. Okay, and our third and last one that we're going to be looking at tonight is the one that kind of makes your brain go a little bit more than anything else, and it's called looking inside. And I don't do this one myself naturally. However, when I do, I'm like, oh, that I like that. But it's something that just kind of, we do a little swap on our brain. So this is called what I call the what method. Some people call it the blob method. Okay. So let's go ahead and look at some examples because you're like, what is she even talking about here? So let's look at an example 4. And like I said, it's how you think about solving it. So we're going to have 2x plus 1 all divided by 2 is equal to 12. Okay, so we're going to replace where the x is with what. Okay, so as I'm looking at this, I see that my x is up here in the numerator. So I'm asking myself, what divided by 2 is 12? So I kind of replace that. What divided by 2 is 12? And I answer that question. So that's kind of the next step there is answer the question. So what number divided by 2 is 12? And that, of course, is 24. So now you're going to simply put your what equal to the answer that you just said in your brain. So what, here's my blob, what is equal to 24. Oh, I forgot my plus 1. So what 2x plus 1 is equal to 24? Because I know whatever this is divided by 2 has to equal 12. So this has to be equal to 24 because 24 divided by 2 is 12. And then you're just solving using our traditional method. So we're going to subtract 1 from both sides. And I have 2x is equal to 23. Divide both sides by 2. And x is equal to 11.5. And then, of course, we can substitute it in. 2 times 11.5 is 23. 23 plus 1 is 24. 24 divided by 2 is 12. Okay, let's try another one. Once again, this is just kind of a weird thing. And once you kind of get in the hang of it, it's kind of fun to figure out how to solve these. So we're going to do the same one that we did up above. X plus 1 squared is equal to 81. And so we're going to go ahead and use our what technique. What squared is 81? Well, 9 squared is 81, and negative 9 squared is 81. So I write my what down, x plus 1. It can be 9, because 9 squared is 81. What can also be negative 9. Negative 9 squared is 81. So we go ahead and simply answer that question and then solve. We've already solved these. So our first one, subtract 1 from both sides, is 8. And our second one, subtract 1 from both sides, is negative 10. So same exact answer, but we're doing it differently. We're thinking about what could possibly be on the inside. Let's look at our very last example for these. And what we're going to do in our activity today is I'm going to have you solve a problem using a specific method or one of your choice, and you're going to answer it and then tell me which method you use. So we have 2 plus x plus 5 is equal to 8. So as we're looking at this, we kind of cover this up. Becomes our question. 2 plus what is equal to 8? Well, we know 2 plus 6 is equal to 8. So we're simply going to set our what, x plus 5, equal to 6, because we know that this has to be 6 plus 2 plus 6 is 8. We're now going to subtract 5 from both sides. And our answer, x, is equal to 1. And that makes sense. 2 plus 6 is equal to 8. So that's called the what or the blob method. And it's one of those that kind of changes the way you're thinking about things. And you have to change the way that your brain is kind of flexing. But it's fun to practice. And it does make a problem a completely different problem, even when it is those same numbers and those same order of operations. So ladies and gentlemen, we're going to go ahead and get some practice of this in today's Desmos activity. Once again, we're looking at ways to make equation solving easier. We can rewrite, we can undo, or we can look inside.